Alrighty, for this last question, we're asked to find the area of the region lying to the right of x equals y squared plus 4y minus 22, and to the left of x equals 3y plus 8. Okay, so let's analyze what they're telling us, really. So we have some region in here. Let's say this region, so let's say we have two graphs, right? So one, let's say, looks like this, and another one looks kind of like that, okay? So here's our region. We'll call it R. We're just going to call it region R, right? And to the left of, so this region lies to the right of some graph. So this region's here, and it is to the right of this graph along, so our curved graph there, right? So this graph must be this first one. So x, and I'll call it x sub 1, okay? And this is x sub 2. So this is x sub 1, the curvy one, on the left. And so to the left, so the region lies to the left of another graph. So here's our region again, that shaded thing, and it's to the left of this straighter-like curve, this line-like curve. So this is going to be our x sub 2. Okay, so that means that our right function, our right one, is going to be our x sub 2. So that's going to be 3y plus 8, and our left one is going to be our x sub 1, which is y squared plus 4y minus 22. Okay, so another thing to note, though we've been doing it kind of subconsciously, I guess, is that because we're using right minus left, or right and left, that means we're integrating along the y-axis. So that means we're going to use our dy, and our interval is going to be on the y-axis, okay? And what is that interval? What is our c to d? We don't know yet, but we can find that out by finding the intersection between these two graphs, the two given graphs, okay? So what is the intersection? We'll find that on the next slide. So we want x sub 1 to equal x sub 2 to find our intersection, where they cross paths, okay? So x sub 1 was equal to a y squared plus 4y, and then minus 22. And on the right side, we had a 3y plus an 8, okay? So when we solve for that, let's solve for y. So we get y squared, and then if we subtract 3y from each side, we have plus y. And if we subtract that 8, we get minus 30. And this is going to be equal to 0. So y is then, we can break that up into y minus 5 and a y plus 6, right, to get that plus 1 in the middle. And so therefore, y is equal to either negative 6 or 5, or and. So the intersection occurs both when y is equal to negative 6 and when y is equal to 5. Therefore, our interval is going to be negative 6 to 5. Okay, so those are our limits of integration along the y-axis. Okay, so now that we have that, we can utilize that. So here's our interval that we just found, and this is in the y-axis, okay? Along the y-interval, we're going to use our dy. Our right function was given by the 3y plus 8, and the left function is given by y squared plus 4y minus 22. Okay, so let's set up our area integral. So the area is going to equal the integral from negative 6 to up to 5, and then we're going to do right minus left, so 3y plus 8 minus left, which is minus y squared plus 4y minus 22, and then our dy at the end there. Okay, so let's go ahead and simplify. We'll solve for this. So negative 6 to 5, and then we have, this is going to become a negative y squared, and then we have a negative y, and a plus 30, okay? So plus 30 there. So that's what we have, and now we can integrate here. So we get our area is equal to a negative 1 over 3 y to the third minus 1 over 2 y squared plus a 30y, okay? And we're evaluating from y equals negative 6 up to y equals a positive 5, okay? So let's continue on the next slide. So we have a is equal to negative 1 over 3 y to the third minus 1 over 2 y squared plus that 30y. And we're evaluating from negative 6 up to 5. Okay, so let's plug in that 5. So we get area is equal to negative 1 over 3, 5 to the third minus 1 over 2, 5 to the second plus 30 times a 5. Okay, and then minus, now we're going to plug in the 6, the negative 6 that is. So if we plug in a negative 6, this is what we'll get. And then for the second term, negative 6 squared plus 30 times, and that's a negative 6 at the end there, okay? So 30 times negative 6. All right, and now what we're going to have is that area is now equal to a negative 125 over 3, and then we have a negative 25 over 2 plus a 150, okay? And then here we have bunch of negatives going on, right? So we have a negative, and this will come out negative, and another negative. So we have 3 negatives, so that's still going to stay negative, and we have 216 over 3. And then this next one is this turns into a positive number, but we have this negative here and another negative, so we have 2 negatives, so that means a positive. We have 36 over 2, and this last one is negative, but we have 1 negative outside, so that'll be a plus 180. Okay, so this is gonna when we add stuff, so we're gonna combine the things over 3. So this negative 125 and negative 216, so that's gonna be negative 341 over 3. Now let's combine the 2 stuff. So that, and then we'll get plus 11 over 2, right? And then this last one, when we combine those, we just get a 330 over 1, okay? So this is going to turn out to be, yes, we are going to have to get yucky common denominators, but it's going to turn out all right. So for this first, we're going to get the common denominator of 6. So here we're going to multiply times 2, so we get 600 and, not 600, hold on here. Yes, so 682 over 6. And then plus, and then this one we're going to multiply times 3, so 33 over 6, that wasn't too hard. And then this one is a doozy, so if we multiply 330 times 6, we're going to get 1980, okay? And this is going to turn out to be a whopping 1331 over 6, and this is a positive number, okay? So this is our final area there. All right, so that does it. That's it for this practice problems video for area between two curves. I hope that helps, and happy studying.